Hello and welcome to my mechanics presentation for Shadows of Freedom. I am going to start with the character mechanics first. This is the animation graph. It holds all the animation states and features for the character. This is the player's animation state. It holds all the animations for the player. It uses a one-dimensional blend space. It is multi-directional by using different animations. The player can turn in place. It also uses blending for the player entering stealth mode. Now on to the stealth mechanics. This is a short clip of the player using the projectile to turn off the lights. The trajectory calculates the start and end position and the velocity of the projectile, taking this data and combining it with a beam particle effect to show where the projectile will hit. The player can hide in the shadows and the light makes the player visible. This uses a mass expression that calculates the player's distance in a sphere collision over the fallout of the light. The lockpicking system uses the player's mouse axes to enable the pin to be moved. When the player finds the correct location, which is randomized, it will shake the bottom pin. This leads into two states. If correct, it will unlock the lock. If there are multiple locks, it will add one onto the counter. The interaction system and inspection mechanics. The player's interaction system uses a line trace that is connected to an interface blueprint. The line trace only reacts with blueprints that has this interface, and it makes it possible to interact with them. In the game, all the quest items are in one blueprint. It uses a strut that runs off a data table where all the information is stored for each item. It is as simple as placing the quest item in the world and selecting the item from the drop-down box. The mechanic is intertwined with most of the other systems. The inspection window allows the player to view the quest items. They can choose an option to return or pick up. It uses a UI system that uses event dispatchers to call the events. When inspecting an item, it uses a timeline to transition the item from its original location to the camera's location. If returned, it reverses this timeline. If picked up, it runs a check in the inventory system before placing it in. It then sets the item invisible and checks if the quest item has an actual quest or dialogue attached to it. The inventory and crafting system. When a player picks up an item, it places an image into the inventory. This in fact is reading from the strut that saved data from the data table. Each item is saved into the slot that is placed together in a grid to make the inventory. When picked up, it checks to see if there is a free slot in the inventory. It then runs a check to see if the item is already in the inventory, and if true, it creates a stack. If not, it finds the first empty slot by running another check. When one is found, it adds the strut data to the slot and then uses the item's name and image to display what has been picked up in the inventory. Two items can be dragged and dropped into the crafting slots and turned into a new item. This runs a check from a data table and checks if the items are a match. It then gets the name for the item to be crafted and runs a similar process to when an item is being picked up. It then removes the items from the inventory. The quest and dialogue mechanics.
Hey fish, I'm the man who knows how to get things, if you know what I mean. Show me your worth, fish.
The dialogue system is a straightforward system. It uses text and audio stored in the data table. Every time a conversation is called, it brings up that information from the data table. The quest system is in the player controller to enable it to be called anywhere. It uses a data table where the row ID number is matched and the quest information is added to the slot in the quest log. Finally, the AI mechanics. The AI uses behavior trees that enables them to perform branches of commands. Currently, the AI is patrolling. It is looking for the next waypoint, and then when it gets to that waypoint, it will play an animation and then wait for a certain amount of time. The AI has other features such as moving to an unusual sound if heard, interacting with the environment if the lights have been turned off, and they can also see the player and will perform checks if they are hiding in the shadows. The last AI uses the environment query system. It runs two queries, one to move to a random location that is safe, and then it runs another to find the best hiding spot from the player. This brings me to the end of the video. If you would like to know more, please visit alandesigns.com. Thanks for watching.